Hi, let us do a quick summary in terms of the design for reinforced concrete beam, slab and staircase. This table can be used as a revision to you preparing for your final exam. If you observe the table here, some of the design are universal and commonly used by the beam, slab and staircase. Some are unique to one of the structural elements, and some are only applicable for the slab and the staircase. It will be rather challenging for you to memorize everything, especially when you see so many equations. However, as you go through the revisions questions as well as the explanations in terms of the comparisons between the reinforced concrete beam, slab and the staircase, you will have noticed something. It seems that the design of the slab and the staircase, they can be categorized as one category, whereas the design of the beam, it will be slightly unique from the other two structural elements. This can help you to have a better understanding in terms of identifying the aspects to be designed for these three types of structural element. First, if you talk about the beam, you know that the characteristic of the beam. The size of the beams is relatively small, and it is a highly optimized structural element, purposely designed to carry the loads. The primary functions of the slab, it will be carrying the load. Therefore, its cross-sectional areas is normally highly optimized as compared to the amount of loads to be carried by the beam. The cross-sectional area relative to the loads is relatively small. As for the slab and the staircase, they are in common in terms of the thin layer structural element and normally have the width of more than 1 meter. In the design of the slab and the staircase, normally we are designed on the basis of 1 meter unit width. And because of its relatively large cross-sectional areas, the design for the moment and the shears are relatively simple, especially when deal with the shear resistance. The concrete member itself is sufficient to carry the shear loads. That's why no shear reinforcement shall be required. On this basis, then we will know how different design aspects shall be applied in the design of the beam, slab and the staircase. These are the equations for singly reinforced member, which is applicable to the beam, slab and the staircase. The loads acting onto the slab and the staircase is relatively low as compared to its unit area. Therefore, the slab and the staircase are not likely to be doubly reinforced. It is possible for the beams to be doubly reinforced. Second, for the shear resistance, normally beam will require the shear link, but this is not required in the slab and the staircase. However, you will need to check whether the cross sections of the slab and the staircase has sufficient resistance to the shear load. That's why you need to find the VRDC and VRDC minimum. You're going to make sure the VRDC and VRDC minimums are greater than the shear loads in order to confirm that no shear reinforcement shall be required. Next, we talk about the serviceability requirements. First is about the concrete cover. By right, all the structural elements will have to calculate the concrete cover, known as the C nominal. This will need to be checked against the fire resistance requirement as defined by the assist distance. You don't find the equations for the assist distance in Eurocode 2 Part 1. Instead, the relevant information is given in the Part 2 of the Eurocode 2. The calculations for the C nominal and the ASD differ slightly. Both, to some degree, will govern the concrete cover. Therefore, you are recommended to convert this assist distance into the equivalent concrete cover and then check if the concrete cover here is sufficient for the desired fire rating durations. So when you are determining the concrete cover, you're going to check these two items, C nominal and the ASD. Next is about the cracking control. The L per D ratios controls the cracking due to excessive bending. All structural elements, when subjected to the bending moment, must check with the L per D ratio. It applies to the beam, slab, and the staircase. However, the areas to be checked vary slightly. The beam and the staircase are checking the L per D ratios towards the directions of bending, which is the longitudinal span. As for the slab, you are actually checking the shorter span. Why is it so? It is because the slab is likely to bend in the shorter span as compared to the longer span. Therefore, it is no point for you to check the L per D ratio for the longer span of the slab. There are quite a number of ways to control cracking. One of them is by the AS-min. For the AS-min, you need to check two aspects. This is given in Eurocode, and this ratio, it will be based on the previous practices. Use the bigger AS-min as the minimum amount of reinforcement bar to be provided in the member. In the case that there are secondary rebar, such as slab and the staircase, the provided secondary rebar needs to be at least 20% of the main reinforcement bar. As for the beam, there is no secondary reinforcement bar. Therefore, this 20% of the main reinforcement bar is not applicable for the beam. As for the maximum spacing, we are talking about maximum spacing between the main reinforcement bar, and in the case that there are secondary reinforcement bar, it also limits the maximum spacing of the secondary reinforcement bar. For beams, you don't really need to check for the maximum spacing due to small cross-sectional area. The spacing available in the beam is not enough to exceed the maximum spacing requirement. You can check, but it is most likely not being exceeded. However, you will need to check for the maximum spacing for the slab and the staircase. Now, the maximum spacing for the slab and the staircase will be governed by the thickness of those members. If the thickness is more than 200 mm, you may use these equations to determine the stress in the steel bar, and then refers to table 7.3n in Eurocode 2 to determine the maximum spacing. In the case that the H, the thickness, is less than 200 mm, these two requirements are applied to the main reinforcement bar and the secondary reinforcement bars. Let's say now you would like to check for the maximum spacing for the beam. A typical beam will have the thickness or the height more than 200 mm. Therefore, this equations is also applicable for the beam. just that the maximum spacing is likely not exceeded. In terms of the maximum bar size, in fact, all the members should check for the maximum bar size. However, normally slabs are quite lightly loaded. The likelihood of the maximum bar size not being fulfilled by this slab is not high. Therefore, if you wish to check for the maximum bar size, you can check for the beam and probably the staircase. The side face reinforcement and the surface reinforcement, they are not applicable for the slab and the staircase. It is not likely to be an issue, as the thickness of the slab and the staircase normally will not exceed 1 meter, and the access distance normally will not exceed 70 mm, and there are little chance for the bar diameter to be greater than 40 mm. This requirement defines the necessity of the side face reinforcement and the surface reinforcement. Although it is written here the beam may require to be checked, however, not all the beam will require the side face reinforcement and the surface reinforcement. Side face reinforcement is for deep beams with a height more than 1 meter. Then you provide longitudinal rebar along the side face of the beam as a measure to control cracking. For typical beams, no side face reinforcement bar should be required. As for the surface reinforcement, also not all the beams will require. Only special types of beam where the axis distance is more than 70 mm or the bar size is more than 40 mm. Then you will need the surface reinforcement. Next is about the maximum reinforcement area. The maximum reinforcement area is set to prevent sudden failure of the structural element. This is a measure for you to ensure the members is always under reinforced, so that the member fail in ductile manner, giving noticeable warnings before the failure. For the slab and the staircase, normally the maximum reinforcement bar is not an issue. As for the beam, it is possible for the maximum reinforcement bar to be exceeded. Make sure it is not exceeded. In the case that the maximum reinforcement bar is exceeded, you will need to redesign the beam section. Probably enlarge the beam, increase the effective depth. This can reduce the amount of reinforcement bar required. At the same time, increase the cross-sectional area of the beam so that the amount of reinforcement bar will not be more than 4% of the cross-sectional area of the beam. The minimum spacing of the reinforcement bar is not likely an issue to the slab and the staircase. Normally, slab and staircase are lightly loaded. However, due to the space constraint within the beam, it may be an issue to the beam. The minimum spacing ensures that the concrete flow through the reinforcement bar and properly surround the reinforcement bar to ensure proper quality of the bond between reinforcement bar and the concrete. Next is about the curtailment. Eurocode is silent about the curtailment. However, based on the previous practices, there are some rules recommended for curtailments for the beam and the slab. Of course, it needs to fulfill certain requirements for the curtailment rule to be valid. You need to know that the curtailment is done in order to reduce the amount of reinforcement bar at the regions where the reinforcement bar is not necessary. At the same time, you prevent the congestions of the reinforcement at the joints between the structural elements. you know that the structural elements, beams and slabs, they are connected to each other and cast together. At the joints, there will be reinforcement bar from different structural elements meeting each others. Curtailment can reduce the amount of reinforcement bar encountered at the joints. To prevent bar congestions, make the construction process easier, and ensure good quality of casting, so that all the reinforcement bar can surround well by the concrete to ensure good bond within the concrete. There are curtailment rules for the beams and the slab. The rules between the beams and the slab vary slightly. You should use the right one to do the curtailment. As for the staircase, I am not aware of any rules of curtailments at the moment. Probably the rules of curtailments of the slab would be applicable. Now, if you are not confident, probably you just don't do the curtailment. This can lead to slightly higher consumptions of the materials used in this staircase. As for the anchorage and the lap length, theoretically you will have to design. The equations are given here. However, the calculations process is rather tedious. Industrial practices, normally they don't like to go through such a tedious calculations. From the educational perspective, theoretically you have to find the required anchorage length and the lapping length, and then round up to the nearest 25 mm. As the industrial practice in the construction site, they are using the inches and feet instead of the SI unit. In fact, the required anchorage length and the lap length is given in the British standard also. Industrial peoples, they prefer to use British standard to determine the anchorage length and the lap length, which normally end up somewhere between 46 to 50 times the bar diameter for typical concrete. Now, if you are not sure the required anchorage length, normally the industrial people will specify of at least 50 times of bar diameter. You know that Eurocode has now already superseded the British standard. By right, for the design of reinforced concrete structures, you will have to follow entirely Eurocode. It is only when there are certain aspects not given in the Eurocode, then you may refer to the latest code of practice, for example, British standard. But what you see in the industry, although they declare the design is based on the Eurocode, but in the design sometimes there are mixture of the Eurocode and the British standard. Normally they prefer the simplified one. Sometimes Eurocode is more simplified. Sometimes British standards is more simplified. From the practical aspects, it is very common for them to mix the design. At least this is what I observe from the local industry. Of course, if you are talking from the education's point of view, you will have to follow through the Eurocode everything. But when you enter the industry for the practices, it is also good for you to know the British standard. As far as what I am aware of, mixing the design between Eurocodes and the British standard, so far there is no reported critical cases, which it seems to be workable. But don't get me wrong, I am not encouraging you to mix the design. You need to be very familiar of what you are doing and know what are the possible risks of your design approach. One of the noticeable differences between the Eurocode, it would be the methods to determine the anchorage length and the lap length. In fact, Eurocode is more powerful in this aspect. because the calculations of the required length has been identified and discriminated by the regions where the lapping length is required, whether it is at the good bond regions and the poor bond region. Because of that, it is likely that the calculated anchorage length and the lap length will be lesser than what is required in the British standard. That means it is more economical. Another major difference between the Eurocode and the British standard, it will be the shear reinforcement. The shear length for the beam, British standard allowed the applications of the mount steel bar, such as R6, R8. However, for the Eurocode, by default, the shear length should be high-yield steel bar, such as H10. But what you see in the industrial practices, although they declare the design is based on the Eurocode, but they are still using the shear length mount steel. R6 and R8 mount steel is easier to work with, especially when they need to bang the mount steel bar manually. That's why the local industry prefer to use mount steel bar as the shear length.